Welcome at KV2 Audio and SLA, Super Live Audio Technology. My name is Stefano Trevisan, and with me is George Campera, co-founder and head of R&D at KV2. The topic of the next video is point source versus line array, George.
We should start from the beginning, no? And on the beginning, we had a box. No, there was speaker, and then they add the horn. No, and that was the beginning. Then they need higher output, and what they did, you just add more boxes together to get higher SPL. So, unfortunately, under this situation, now we're talking about two axes. No, then you have a huge interference between all the components there, drivers, and there was a good solution to reduce that problem, and we came up with line array. Line array is basically the same thing, whatever was done for the speech a long time ago. It was common, every company did it, no? They had typical things, they have like 8 speakers, 8 inches, no? And that was used for the speech, no? But for high SPL, no, and better reproduction, they, from 2 axes, they went to 1 axis. No, that's the line array. No, but line array still has a problem because there's too many components. No, and when we listen here, no, we can hear sound from here, no, from here, from here, from here. And when we are far enough, you will find out that actually, because that has a dispersion usually 7 to 10 degrees, no, then you can find out that you hear all those points
all the
here
speakers.
Only because the distance is different, no, then you hear each speaker in different time. What happens actually if you listen
so all the speakers, also in the high frequency, cover the same area at a certain distance.
Yes, exactly. And that means now, if you take one speaker, no, and put a pulse in, that will be our result, no. But as we start adding speakers, no, because that pulse came later, no, and then you find out it's another one here. Another one, another box, another box, another box, another box. And then you end up, no, we listen, I feel, let's say 10 kilohertz, which is 100 microseconds, no. You hear high frequency, 100 microseconds, for the time up to 2 milliseconds, no. That means you completely lose your definition, completely, no. And another problem is, because the signal lasts longer, no, to get the feedback, you need time to develop the feedback. No? And in this case, no, it's more sensitive to feedback. No? If you have a point source, advantage of the point source, it stops immediately. No, it's way more resistive to feedback. Typical example was, for example, we had a concert, and there was a guy who walked, actually a singer, in front of the VHD2, like 1.5 meters from the box. Everybody was scared what was going to happen. No feedback. No. That's
just because the signal just stops.
Stops immediately. No. And that is guaranteed by, number one is it's a single point. And second thing, it's good control of the speakers. No, drivers. That means they stop immediately. To stop the speaker, no, in point source, that's what we're doing. And I'm going to clean up this thing now. We don't need it. Mm-hmm. It's obvious, no. And stop the speaker, the big problem is, in the speaker, it's inductance, no. And it's a similar thing, like we put the hand here, put the spring here, and we put the mass. That spring here represents an inductance. As we move with the hand, the mass doesn't follow the movement. No, when we reduce the inductance or eliminate the inductance, now there's direct connection, and now the mass will control. No, and what we did, no,
So it becomes a resistance. It's not a
it's
true
just a
resistance.
resistance, yes.
Yeah.
And now, no, a typical result is a typical speaker has a impedance response like that. Impedance response of our speaker, it's like this. No inductance. Because there is no inductance, there is no distortion. Simple. Because the distortion, mainly a third harmonic distortion, now referred to the modulation of the inductance. If there is no inductance, there is no distortion. Simple as that.
So having a point source in the end and using all the advantages, you need to have the proper electronics too, just to
Yes.
be able to reproduce
Yes.
the information.
No, because the distortion of that speaker, it's really, no, it's very, very low. We measure 0.3% mid-frequencies at 1 kilohertz. No. In the same time, what we need a true piston motion compression driver.
Yeah. You were saying that with the major change from horizontal and vertical aligning of single speakers, the achievement of the vertical line array that has been done also in the past for churches and for speech, resolved that problem of the horizontal interference. Is that true? Do we not have any horizontal?
It's not totally.
Yeah.
No, because you still have one problem. We have a vertical and we have a horizontal, but under that angle, it causes a real problem. No, and you can tell if you're gonna listen to the system as you're walking across. No, the sound is changing. If it will be true line array, as they say, no, it won't happen. But it does happen because ideal line array works at low frequencies,
Yeah.
not above.
Yeah, you can.
Yeah.
Everybody knows that feeling with pink noise and moving around
Yeah.
in an area where a line array is working. You hear the difference. Yeah.
Okay.
Okay, I think the advantage, you talked about the SPL. So how do we get higher SPL with a point source speaker?
What we did actually, you sum few drivers together. That mean you're getting actually the horn, which has a high output, no, and has a 3 drivers behind, no, and because, no, as theory says, and as the measurement just prove, no, in line array, 10 speakers, no, it's equal to 1 speaker in point source.
What causes this loss of energy or this loss of SPL?
And that part caused of cancellation on high frequency. That means the line array doesn't sum at high frequencies.
Yep. It's because there are still small delays in
Yes.
between, so it interferes. And how does also temperature affect
And
a line
that's
array?
another major problem. Nobody published that, but really, no. And in the 90s, I heard the system that was VDOS, and sounds was pretty good, no, before people show up. When they were setting up the system, when people show up, the high end disappear, no, and disappear because air above audience, no, start moving up, no, and as it's moving up, it start actually changing the distances, and perfectly, no, cancel the high frequencies.
Yeah, it changes the direction
Yeah,
of the
changing not
The
just the
waveform.
direction, but the length.
The length.
Actually, no, the path, and therefore, no, it cancel. There's almost zero, and everybody basically went through this thing. They can hear under the wind condition, the sound just disappeared completely.
Totally disappeared.
Some part of it. No?
Can you draw a diagram that shows the loss of SPL in line arrays?
Like if we have,
Because a line array
if we have one box with straight line, we add another box, and what we will end up will be some COM filter. No? As you start ending more and more, no, you will find that it's smoother, but the concentration of high frequency is huge, and typically is 10 dB to 10 kilohertz. No, and therefore at 10 kilohertz, one driver has the same output as 10 drivers in line array. Now we are back to our system, which we're currently developing. Now, it's a VHD5, and here we have actually small horn for the high frequency, a large horn for the mid frequencies, and large area for low and mid. No, and here advantage is this, because the dispersion is controlled very well, and it's same on every frequencies. Therefore, we have a constant power. No, and that's why we call it constant power point source, because really that represent our mid frequencies, that represent high frequency, that represent the rest. That means this is 45 up to 400 hertz. No, that part it's 2K up to 20K, and this part here is 400 hertz up to 2K. And this way, we basically produce constant power on every frequency. Advantage of that, you have the same sound everywhere.
Yeah, every band.
And because there is only one point when the signal comes from, have nothing to cancel with. Therefore, you can get the simples across 100 meters without any problems. No. You just have to count with the losses through the air. And we find out here at 50 meters, you need about 6 dB boost. Now, in 100 meters, it's about 12 dB boost to get a flat response. No.
Yes. Okay. What can you say about the definition over distance of a system like this one?
Yeah, it's a definition basically because we have a relatively huge loss in the air. No, then and we have actually in the catalog we have a nice picture which really represent the problems. No, and as you're losing when you're going through the air, we're losing the high frequencies, and we can say we're losing the definition. We can have, let's say that is our threshold of the sound recognition. No? And you can see if you have a lower quality to begin with, no, apply same curve, the distance is different.
Mm-hmm. Yeah.
That means a higher quality you have on the beginning, further you're gonna get high quality sound.
Yes.
And this is the main difference between multiple point and only point source.
Okay. Thank you, George. I hope you enjoyed this video, and thank you very much, and see you soon.
Did you know that a simple speaker completely transformed modern music festivals, affecting everything from sound quality, festival layout, and stage design?
When I first heard vertical line array, I knew as soon as I heard it that that was the way of the future.
This is Dave. He's a sound engineer and sound system designer who's worked on festivals before and after this change, and has provided audio for Coachella since 2001. How did this speaker affect audio quality? Ideally, you'd only want one speaker to cover an area, but for concerts, you need multiple.
What do we do when you have more than one speaker covering an area? There's two different basic theories or concepts on ways to do that. One is point source.
With point source, each speaker acts independently, creating multiple sound waves that hit the audience at different times, like a firework or showerhead configuration. This creates inconsistent sound, meaning you'd hear the music very differently if you stand here versus here. So, how do we fix that?
With a line array, we have a speaker, and instead of putting one alongside of it, we put another one above it and below it and above it and above it. Now, as you walk across the horizontal domain, walk across side to side, you only hear one speaker. If you were to go up and down, you'd hear the problems, but line arrays pile all the problems up where we hear them least.
So what does it sound like if you were to walk across a field with a point source speaker versus a line array? What we're hearing is called a comb filtering effect, when interference causes the same sound to be heard with a very small time delay between signals. This is the type of audio interference we'd hear in a point source system.
Fairly beamy sounding, kind of hot spot in the middle and fades on the left and fades on the right. What if we take that same thing and we configure them into a line? But look what happens vertically. That's what line arrays do. They allow you to walk side by side and have a very smooth sound, very similar to a single driver. Because in the horizontal domain, should we slice it, that's all we have.
Line arrays made sound clearer and more evenly spread, so that almost anywhere you stand, the show sounds similar.
First concert I heard it, it sounded like the PA was closer than it physically looked. It was kind of messing with my mind. It was, how can it sound so close and look so far? I'd never heard anything like that before.
How did line arrays help create today's festival layout?
If we have multiple stages on a festival ground, one of the big challenges is preventing sound from this stage from affecting this stage.
With the use of laser rangefinders, 3D mapping, and precise angling, sound designers can not only make sure music from neighboring stages don't bleed into one another, but that there are no dead zones throughout the festival grounds. That means that wherever you stand, you're still able to hear music.
We used to walk into arenas and just draw a bunch of X's, like, oh, put a motor there, put a motor there, put a motor there, put a motor there, and fly them up to 40 feet. And that should do it. It was all eyeballed. When line arrays were released, Acoustics released software that allowed you to determine down to a fraction of a degree the angle between the boxes. We can now aim sound to a certain distance and then have it taper off relatively quickly. We've gained the ability to really cover specific areas.
We showed Dave images from past festivals to see how much they've changed.
Here, if you look at this, behind these rainbow scrims, there is 90 boxes per side. Each of those boxes is 4 foot high by 4 foot wide. That's huge and heavy. Takes a long time to set up. Fast forward, here's Coachella 2011, also doing a big field gig. And we've gone from 90 speakers a side to these tall, slender line arrays. This was 2001, the first year that we did it. And here we can see the Rat Trap rigs, a system I designed that is 4 deep, 6 wide, kind of an old school system before the true line arrays came into play. So this is when we bought our first VDOS rig, and there is the line array. So this is, the festival's grown, and you can see that there's less PA, or seemingly less PA, yet the volume and coverage was actually louder. Now this one here, it looks bigger. It's actually 2 line arrays side by side, and that's my fault. Line arrays should never be put side by side. They interfere with each other, but I solved it by not running the same signal into both. I actually have 2 PAs here. One for vocals and drums, and another one for guitar and bass. They were completely separate, and that was absolutely amazing. And here is The first year we got the new system. This is a K1 system. So now we could hang 24 boxes deep instead of 14. This was the largest deployment of this sound system that had ever existed in the world to date. Look at the change in this year from those drops and then video screen behind to video screen. There's Guns N' Roses. Look at that. Now here what they've done is they've taken that sharp edge out of the screen and made it smooth. And that's all high resolution video all the way across. If you really think about it, we want to hear sound, we don't want to see it. If we could make the sound system invisible, we will have won. We want to just hear it. And line arrays helped us get a heck of a lot closer to that.